All right, guys, today we're going to start by translating the message on your screen. This is a text message that was sent, and it reads, "Oh my goodness, did you check out Facebook last night? Totally crazy stuff going down at Salyards. Laugh out loud. For real. Love you. Talk to you later, Mrs. Hyjic." This is an abbreviated message, not completely spelled out. Why do you abbreviate in text messages? Well, it's easier and faster to abbreviate a word than to spell it out. Well, scientists do the same kind of thing. They can use abbreviations. These abbreviations are known as chemical formulas. A chemical formula uses symbols, element symbols, as an abbreviated way to write a compound name. A chemical formula tells you three very important pieces of information about a compound. It tells you the elements that are found in the compound. It tells you the number of atoms of each element there are in that compound. And it tells you the number of molecules of each of that compound. Your action item for today's Wix is to list the elements found in these following chemical formulas, which represent compounds. So I want you to turn your Wix over. You're going to write the chemical formula, and then you're going to list the elements that are found in that formula. So do you know the chemical formula for water? I bet you do. It's H2O. This is the chemical formula, an abbreviated way to spell out water. This chemical formula tells me that there are two elements found in a water compound, hydrogen and oxygen. It's important that you know your chemical symbols in order to interpret chemical formulas, and that's why we had you make those flashcards a little while back. The next chemical formula is for salt. Do you know the chemical formula for salt? Well, you might have. It is NaCl. Sodium chloride is the name of this compound, and it is composed of two elements, sodium, Na, and chlorine, Cl. The next chemical formula is the chemical formula for chalk. Bet you don't know what this one is. It's CaCO3, or calcium carbonate. Calcium is the symbol Ca. Carbon is the capital C by itself, and oxygen is this capital O. This is not the chemical symbol for cobalt, because in a chemical symbol, remember, if it is a two-letter symbol, the second letter will be lowercase. And since this O is a uppercase O, it represents oxygen. And our last chemical formula for this action item is carbon dioxide. You might know this one. That's CO2. Carbon dioxide is composed of two elements, carbon and oxygen. Again, this is two individual elements, not cobalt, which the symbol for cobalt is capital C, lowercase o. So it's really important that you guys can determine where one element ends and the next element begins. Within chemical formulas, you have some numbers known as subscripts. Subscripts are the small number written to the lower right hand of a symbol. And the subscript tells you the number of atoms of that element that are in the compound. For example, water. The chemical formula again was H2O. So hydrogen and oxygen make up water. But how many hydrogens and how many oxygen atoms are found in a water molecule? Well, this is a subscript. It's found to the lower right-hand side of the hydrogen. So this tells me that there are two hydrogen atoms in this chemical formula. Now notice there's no number written to the bottom right-hand side of the oxygen. Well, it's understood then that there's only one atom of that element found in the molecule. The reason they don't write the one down here is because the symbol being within the formula is telling you that it's there, at least one of them. If there's more than one atom of that element, they will tell you by using a subscript. Let's try this one. Remember salt, NaCl, sodium, and chlorine are the two elements found in this formula. How many sodiums do we have? One. How many chlorines do we have? Only one. Since there's no subscript to the lower right-hand side of either the sodium or the chlorine, it's understood that there is only one atom of those elements in the compound. Here's another example. There's the calcium carbonate. We have one calcium, one carbon, three oxygens. And lastly, carbon dioxide, made of carbon and oxygen, 1 carbon, 2 oxygen. So we use those subscripts to determine the number of atoms of each element in the compound. You're also going to see another number called a coefficient. A coefficient is a large number that's written at the beginning of the chemical formula, and it shows you the number of molecules of that compound. For example, here is a coefficient added in front of a water compound. This tells you that there are 2 water molecules. So instead of 1 H2O, there are 2 H2Os. Therefore, instead of only 2 hydrogens, we end up with 4 hydrogens. And instead of 1 oxygen, we have 2 oxygens. So you take your coefficient and you multiply it by each element. So 2 times 2 is 4 hydrogens. 2 times 1 is 2 oxygens. How about this one? How many molecules of salt do we have? Well, we have 3 because there's a coefficient here. We have 3 NaCl's, which means we have 3 times 3 sodiums and 3 times 3 chlorines. Okay. The next example is the calcium carbonate. The 2 in front of the calcium carbonate chemical formula tells me that I have 2 molecules of calcium carbonate. That's 2 calciums, 2 carbons, and 6 oxygens. So making sure you understand the difference between a subscript and a coefficient, let's take a look at this illustration. This illustration, I want you to match the picture, the top picture or the bottom picture. Does it go with the O2 over here, or does it go with the 2O2 over here? Well, the O2 with the subscript 2, O2, is this one, because that's telling me that there are 2 atoms of oxygen. This one matches this picture because there's the coefficient here, which is telling me I now have 2 molecules of O2. So 1, 2, 3, 4 oxygens versus 1, 2 oxygens. Organic compounds are a special group of compounds that are associated with living things. All organic compounds are going to contain 3 elements. You're going to find carbon, hydrogen, and oxygen. If it doesn't have carbon, it is not considered an organic compound. Most organic compounds that will also have the hydrogen elements and the oxygen elements. Some examples of organic compounds that we're going to be studying at the end of the year are carbohydrates, proteins, lipids, and nucleic acids. For today, all you really need to know is that organic compounds contain 3 common elements: carbon, hydrogen, and oxygen. All right, now we're going to quickly add to a chemical formula, because a chemical formula is a shorthand way of writing out a single compound. But if I want to write out a longer reaction, then I'm going to use something known as a chemical equation. A chemical equation is a short, fast way of writing out a chemical reaction, and it uses chemical formulas, which we just learned about. So which way would be easier? Writing out calcium carbonate yields calcium oxide and carbon dioxide, or would it be easier to write this? CaCO3, arrow, CaO plus CO2. Well, if you know your chemical symbols and you know your chemical formulas, this way is going to be a lot easier and faster to write out a chemical reaction than this. And so this down here is known as a chemical equation. It's like texting. It's just easier and faster. Well, in a chemical equation, we have 2 different parts. We have the reactant and we have the product. So here's that formula, not a formula. It's an equation which uses formulas. We have this chemical formula here for calcium carbonate, and we have this chemical formula here for calcium oxide, and this formula here for carbon dioxide. So within a chemical equation, you need to be able to recognize reactants and products. Reactants are what we begin with, what we start. They're the substances that are going to be reacting in our chemical change. You will find those to the left of the arrow. There's the arrow. Every chemical equation is going to have an arrow, and that arrow is going to be the line that divides the substances that we start with, the reactants, and the substances that we end with, which are known as the products. The products will always be found on the right-hand side of the arrow. So the compounds that are reacting that we have before the chemical reaction or the chemical change takes place, those are the reactants. And then the new substances that are produced or formed as a result of the chemical change, as a result of the chemical reaction, that's what we have afterwards. Those are called the products. Now the arrow is a very important piece of a chemical equation. That arrow represents the chemical change or the chemical reaction that's taking place. And when you read a chemical equation, when you get to an arrow, you use a couple of different words. You might use produces, or you might use the word yields. So that's what you say. So if I was reading this chemical equation, I would say calcium carbonate yields calcium oxide plus carbon dioxide. Or I might say calcium carbonate produces calcium oxide and carbon dioxide. Now, what I want you to understand is that the reactants do not equal the products. Now, in a math equation, what you start with equals what you end with, but that's not the same with a chemical equation because reactants are not the same as products. So let's talk about that. In our equation, calcium carbonate produces calcium oxide and carbon dioxide. Calcium carbonate, that's the chalk. And some physical properties of chalk is that it's white, it's brittle, but calcium oxide is limestone. It's white, but it's a very hard rock. It's not brittle at all. So it's got completely different physical properties than what it started out as. Carbon dioxide is a gas. It's a colorless, odorless gas. And so you can see here that what we start with is not the same as what we end with. So we never say equals. We say that the reactants produces the products, or the reactants yield the products, but they never equal the products because our products will always have completely different physical and chemical characteristics than the reactants that we start with. So once a chemical reaction takes place, the reactant is changed into another substance. We no longer have what we started with. We have something completely different. But notice, we still have calcium, carbon, and oxygen. We start and end with the same elements. The elements just rearrange to form completely new products. And one last example of a chemical equation. Here I have the element sodium. Sodium can combine with chlorine atoms to produce sodium chloride or salt. We saw that chemical formula earlier. Sodium is a solid metal. I would never eat sodium. And I would certainly never want to inhale chlorine because it is a poisonous gas. But if I take these two reactants and they undergo a chemical reaction with one another and they combine to form a compound, this compound, sodium chloride, is white and grainy and it tastes good, and I add it to my French fries and it's delicious. But I would never, ever, ever consider eating sodium and chlorine in their elemental forms. So I wouldn't eat them as reactants here, but I certainly would eat them as a product because our products are brand new substances that are formed. They're completely different than the reactants that made them up. They have different chemical properties and they have different physical properties. And we will continue to talk about physical and chemical properties in the days to come. Talk to you later.